Hello everyone, welcome to my YouTube channel. Today I am going to present on business plan for energy harvesting shoes. So let's begin. This is the logo which I am going to use and the brand name is Electrogen Shoes Private Limited. Now let's start with the description. Have you ever had a moment when you had a very important text to send, but before you could finish sending it, your phone died? Pretty much any person with a mobile phone device has experienced that frustrating moment when a device fails to perform its task due to lack of energy. My project is designed to fix this problem in a way that promotes health by creating a shoe insole that converts the physical energy created by walking into electricity, which is then stored in portable battery pack. This way, you will always have an emergency power source and you will be renewing some of your own physical energy too. Now we will see the design part. In order to fully appreciate the science behind this project, it is helpful to understand how it works. Essentially, the main power source that makes this project possible is something called as piezoelectric transducer. The piezoelectric transducer or piezo elements are comprised of materials such as crystals and certain ceramic that have a special property which allow them to convert physical energy into AC electricity, that is alternating current. Fortunately, we can take advantage of this special property by putting piezoelectric element underneath our feet in such a way that every time we take a step, we are using our weight to push on the piezoelectric element, which then in turn convert that energy into electricity. The only issue with this, however, is that we need DC and not AC. That is, we need direct current and not the alternating current in order to power our stuff. We can solve this problem by creating a bridge rectifier with diodes to convert the AC power to DC power, which we can use. The first step is to measure the shoe insole and make the profile of the insole accordingly. Now, in order to make our piezoelectric generator, we are going to need a plastic base. The piezo element holes are strategically placed so that they line up with the large indent on my shoe insole, which indicates the area of most pressure. These files are based off my foot, which is a size 8, that is UK size 8. Although my heel piece fits perfectly, my toe piece requires a good bit of sanding in order to get it to fit properly. As you can see in this image, the sanding is being done to the toe piece. Next, gluing the piezo elements in figure as shown in figure. Once we have finished creating the base for our piezoelectric generator, it's time to hot glue them on. I found that the best technique to glue the element to the board was to apply a thin layer of glue around the edge of the hole in the plastic, then quickly pressing the piezo element onto the glue before it cools. But be careful to apply the glue because it may restrict. If you apply excessive glue, then it may restrict the foam pads which will glue on the top of the piezo elements from fully compressing. Also, make sure the glue does not cover the contacts point of the black and red wire because we will be soldering to this point soon. Make sure you glue piezo elements on both sides of the plastic. If you have a multimeter, you can ensure that your piezo element works by setting the multimeter to AC volt and pressing on the piezo. After you have glued all the piezo in their appropriate spots, you can then glue the foam cardboard pieces onto each piezo element. Now, next step is to solder, that is soldering the piezo elements together. As you can see the images, although physo elements generate plenty of voltage. They do not generate many amperes. That means the current generated by physo element is on the lower side, but the voltage is on higher side. We can solve this issue by wiring all the piezo elements in parallel. That is, in other words, the positives are always soldered to each other and the negatives are always soldered to each other. In this way, we will be able to increase the amount of amperes and consequently charge our device faster. In order to prevent wires from breaking off, the solder joints use hot glue to fasten parts of wire in place so that the stress on the wire is not enacted upon the solder joints. You can connect the piezo elements from one side of the plastic to other side by threading the wires of one of the piezo element through the holes so that they can be soldered in parallel to the piezo on the other side. Once all the piezo elements on the heel piece are wired in parallel, solder the last piezo in the chain to on one of the piezo element on the toe piece and continue to solder the piezo element in parallel until all the 7 elements are connected. Now, blueprint. All the elements required in this project are mentioned below. First and most important is the shoes. Then we need piezoelectric elements, that is 7 numbers. Then we need rechargeable battery packs with charger. Then we need hot glue gun with hot glue, soldering iron plus solder, foam and cardboard. Access to 3D printer. That means we need to print the profile of our shoe insole by using a 3D printer. And 4 diodes, that is 1N4001 or 1N4007 diodes of 4 numbers, or we can get it from CFL light bulb. Things that will be helpful apart from the important things like Dremel tool, helping hands, velcro strips which are highly recommended, and multimeter, heat gun if we are using if we are taking out the diodes from the CFL bulb, and ruler and calipers. Now the waste usage. In this project, once the product is manufactured, the waste is negligible, but here we can utilize the waste, that is USB wires which are like it is outdated, or the CFL bulb which are out of use. So we can take that and we can utilize them. In CFL there are many diodes which we can take out and use in our project. Now if you are not having any diodes, if you are having diodes you can skip this step, and if you are not having diodes then you can follow these steps as mentioned, and you can collect the diodes which are required for this project, and which we will be using in creating the bridge rectifier for converting AC to DC. A normal CFL contains around 6 to 8 black diodes, and uh, you can easily indicate the positive ends by finding the gray strips on them. So next step is, now we will see how we will build the bridge rectifier. Okay, so for those who don't know how to read a circuit diagram, those 4 line segments with arrows on them represents the diode, that is D1, D2, D3 and D4. They represent the diodes. The arrow allows the point to the side of the diode that is marked, are also known as the positive side. If you have a small rectangular diodes like me, the positive sides are not marked by coloration but rather small engraved lines, notches, etc. By following this diagram, you should be able to create a bridge diode. This is an image of diode and this side indicates positive. Now wiring the bridge rectifier. Wire the physo elements wire to the bridge diode according to the circuit diagram shown. Since the current is AC, the position of the wires are interchangeable as long as they connect to correct diode in the diagram. Strip the USB charge cable that come with your battery packs to reveal the internal wires. For this purpose of for this project, we will only need the red and black wire. So strip those as well. Twist and frayed wire strands of each wire and tin them with solder. Solder the wire to the bridge diode accordingly. Be sure to check the polarities since DC voltage has positive and negative terminals. Hot glue the connections to prevent the wire from breaking off. As discussed in previous slide, these are the images showing how to uh, wire and how to solder and connect the bridge circuit with the piezo elements and how to use this USB cable wires. Now the installation part and finishing touches. Once we have finished wiring the piezoelectric generator, we are ready to install it. All you need to do is slip the plastic piezoelectric generator inside of your shoe, then insert the original sole on top of it. Take the USB cable wired previously and thread it between tongue and the outside of your shoe as shown in the picture. In order to mount the battery, stick it between the tongue of your shoes and the lace and tie your shoes tightly. If you have a Velcro, I would recommend using it to better fasten the battery pack to prevent it from falling out while running. I will also recommend making a foam cutout of your other shoes sole so you can use it as a riser in your shoes with no generator in it. I used my shoe that did not have a piezoelectric generator in it as a storage for my mobile device charger cable. So I will always have everything I need for charging, as you see in this image as previously discussed. Now the last step is to generate electricity, and how to generate electricity is to wear the shoes and start walking and generate the electricity as shown in the figure. Now, the most important part of the project is cost estimation and the price factor. The major component of price are shoes, piezoelectric material, 3D printing cost, rechargeable battery and charger, advertisement, distribution, that is logistics and sales. So price cost are for shoes we will be needing 600 rupees. For piezoelectric material we need 420 rupees. For 3D printing we need 200 rupees. For rechargeable battery packs and charger we need 340 rupees. And for distribution, advertising, logistics, sales, marketing we need 80 rupees. And the minor components like diode, soldering gun, hot glue gun, cardboard, etc. we need 50 rupees. So total cost of this project is around 1690 rupees. Now, advertisement. Target audience are college student, school student, corporate employees, bikers, mountain trekkers, traveling people, health conscious people. With the right mix of social media, online strategies, sponsorships, sales promotion, we will achieve our target. Social media, that is creating ads on YouTube, Facebook, Instagram, Twitter, search word optimization will be helpful in advertising. Sponsorships given to marathons, stay healthy shows, college fest, school fest, etc. And by doing the sales promotion like giving samples outside colleges, schools, universities. Now the selling plan amount. As we know that the cost of the shoes is 1690 rupees. To add profit margin to that, that is 25%, we need to add around 422 rupees on the cost price. That is selling price now will be 2130. Now the most important slide. Why this product is important? To harvest wasteful vibration energy of a walking pedestrian and converting that into a useful electrical energy for our charging purpose is the main purpose of this project. We can charge the following like mobile phone, GPS location. It can be used in lady security, safety. Then it can be used by uh, trekkers when they go for mountain trekking the mountains. Then we can use for wireless earphones, earring head, smart watches, AAA batteries for charging AAA batteries, and it can also serve as a portable energy source and can be used in monitoring individuals' health parameters like blood pressure, pulse rate, etc. Now the customer care ID is customer support at electrogenshoes.com and the contact number is 1800 022 0012. If you have any questions, please ask. Thank you.